On April 8, 1941, at exactly 2:35 in the afternoon, a massive four-engine aircraft rolled onto a runway outside Tokyo. It was enormous, over 100 feet long, a wingspan stretching close to 140. Four engines thundered as it accelerated, lifting into thick, humid air while Imperial Japanese Navy officers and Nakajima engineers stood perfectly still, watching like men waiting for a verdict, because this aircraft wasn't just a prototype. It was a secret. It had taken 18 months to build and nearly $1 million to acquire the American airliner it was based on. A plane Japan had purchased through a civilian front, shipped in crates across the ocean, reassembled under the disguise of an airline flagship, and then killed in public with a fake crash story to make it disappear. Now, in its true form, stripped of innocence and rebuilt for war, it was airborne, and within minutes the dream began to crack. The pilot pushed the throttles forward. The aircraft climbed, but too slowly. The engines strained like they were trying to lift a building. Controls felt heavy and sluggish, the kind of response that tells a test pilot one thing: this machine is fighting itself. Something was wrong. And the worst part was, something had always been wrong, because Japan hadn't stolen a miracle. They had stolen a failure. They had reverse engineered an American four-engine future airliner that the U.S. airlines had rejected as too complex, too heavy, too expensive, and too impractical for real service. Japan believed they could copy it, improve it, and turn it into a strategic bomber capable of striking across the Pacific. Instead, they created one of the worst heavy bombers in aviation history. This is the story of how Japan bought America's rejected airliner, faked its death, dissected it in secrecy, and built a bomber that couldn't bomb. And it begins in the golden age of American commercial aviation, before the theft, before the deception, before the war. In the mid-1930s, aviation in the United States was transforming fast. Airlines expanded routes. Passengers grew confident. Manufacturers competed to build the next aircraft that would dominate the skies. Douglas had already changed everything with the DC-3, an airplane so successful it became the backbone of commercial flying. But success creates obsession. Airline executives didn't want good. They wanted revolutionary. United Airlines leadership dreamed of an aircraft that would make the DC-3 look obsolete overnight. A four-engine passenger plane that could cross the entire United States without stopping for fuel. It would carry dozens of passengers in daylight service or sleepers for overnight flights. It would feel like the future, smooth, quiet, comfortable, and unstoppable. The problem was simple. The future wasn't ready. A four-engine airliner meant engineering problems that hadn't been solved before. Wings strong enough to carry four engines and still remain efficient. Landing gear that could handle massive weight. Electrical systems, hydraulics, fuel lines, and structural reinforcement, all inside a passenger aircraft that still had to be practical and maintainable. Douglas took the challenge anyway. Teams produced thousands of drawings, endless tests, and an extraordinary amount of labor to build the prototype. When it finally emerged, it looked like a new era. It had tricycle landing gear, a modern stance, and a giant wing carrying 4 powerful engines. It even used unusual design solutions, like multiple vertical tails, to fit inside existing hangars. Everything about it screamed advanced. Then the real world touched it. Test pilots could fly it. That wasn't the question. The question was whether airlines could operate it every day, on schedule, within budgets, with mechanics trained on simpler aircraft. And the answer, slowly, painfully, became no. The prototype was too complex. Maintenance demands were too high. Its systems confused crews. It drank fuel. Range fell short of promises. And when airlines increased passenger capacity to make the economics work, the aircraft became heavier, slower, and less capable. Weight was the silent killer. Every fix added more weight. Every improvement created new problems. Every new system demanded reinforcement. The engines that looked adequate on paper now struggled. The aircraft wasn't a total disaster. It was worse than that. It was an impressive machine that couldn't be justified. One by one, airlines backed out. Douglas was left with a beautiful, expensive problem sitting at the factory. An unwanted prototype and a development program bleeding money. And then Japan appeared with an offer that looked too good to refuse. A Japanese trading company approached Douglas and offered $950,000 for the aircraft. Officially, it was for a civilian airline, Japan Airlines, expanding routes across Asia and the Pacific. To Douglas, it sounded like the perfect exit. There were no obvious red flags. Civilian aircraft exports weren't heavily restricted. Foreign airlines bought American aircraft all the time. So Douglas agreed. But Japan Airlines wasn't the real buyer. It was a mask. Behind it was the Imperial Japanese Navy. Because Japan wanted something it couldn't easily build, a true 4-engine long-range aircraft, something that could become a strategic bomber. Japan had brilliant fighter designs and capable twin-engine bombers. But 4 engines meant a leap in systems knowledge and production capability they simply didn't yet possess. So they chose a shortcut. Buy the American prototype. Study it. Copy it. Improve it with Japanese engines. Transform it into a weapon that could strike far across the Pacific. They disassembled the aircraft, shipped it in crates, and Douglas, without understanding what it was enabling, sent engineering data, manuals, drawings, performance material, even wind tunnel work. A Douglas technical team traveled to Japan to help reassemble it. And while the Americans worked like professional customer support, Japanese engineers watched every step like intelligence officers. Once assembled, the aircraft was painted in airline colors and shown to the public like a symbol of progress. Then it vanished, and Japan offered the world a story. The airliner had crashed into Tokyo Bay. Nothing recovered. No more discussion. A clean, final ending. It was fiction. The plane hadn't died. It had simply moved into the dark. Hidden at Nakajima, it was dismantled piece by piece, measured, weighed, photographed, documented, reverse engineered until the aircraft became a library of parts. And from that library, Japan attempted to build its first four-engine land-based bomber. The result was the Nakajima G5N, named Shinzan, Deep Mountain, a name meant to sound immovable, massive, permanent, and in appearance, it was. It borrowed the wing layout and overall size. It used similar landing gear concepts, but now it carried bomb bays, defensive guns, a military cockpit, and the dream of strategic reach. The Navy believed the biggest weakness of the American prototype, its weight, could be solved with a simple idea: more power. So they installed ambitious Japanese engines that were supposed to be stronger than the American ones. But ambition is not output. On the first flights, the engines didn't deliver the promised power. They ran rough, overheated, required constant attention. Reliability collapsed. To prevent failures, engineers reduced power settings, which made performance even worse. And the aircraft itself, heavy, oversized, and born from a rejected design, handled like a tired animal. It climbed slowly. It responded sluggishly. It couldn't reach the speed needed to survive in modern air combat. Its ceiling was limited, and most critically, its range failed the very requirement that justified its existence. Japan wanted an aircraft that could reach far targets across the Pacific. What they got was a giant bomber that struggled to meet even nearer operational demands. They built more prototypes, tweaked cowlings, adjusted prop pitch, modified systems, swapped engines, tried reliability engines that were weaker. The bomber became safer and more useless. It entered a vicious circle. Push the engines and they fail. Reduce power to keep them alive, and the aircraft becomes incapable. By 1942, the truth was undeniable. Shenzhen was a failure. Not because Japanese engineers lacked talent, because they had attempted to steal a finished result without the painful understanding behind it. They could copy the wing, but they couldn't copy the years of mistakes that explained what not to do. So the Navy did what militaries do with expensive failures that can still fly. They repurposed it. Weapons removed, bomb bay sealed, armament reduced, crew reduced, and the strategic bomber became a long-range transport. The aircraft designed to terrify American cities ended up hauling cargo and personnel to distant bases: Hong Kong, Formosa, the Philippines, island garrisons that needed supplies. $1 million secret reduced to freight. All that deception for logistics. Even Allied intelligence misread it at first. Reconnaissance photos showed a massive four-engine aircraft, and analysts assumed it was a strategic bomber threat. They assigned it a code name and prepared for scenarios that never happened, because the bomber that looked dangerous on film was already dead as a weapon. The true irony came after the war. Douglas, the company that suffered through the failure, learned from it. They redesigned the concept into something simpler, lighter, and practical, an aircraft that would become a wartime transport backbone and a post-war success. Japan, meanwhile, copied the failure and made it worse. And that is the lesson hiding inside this story. You can steal metal. You can steal drawings. You can steal shapes. but you cannot still the institutional memory, the invisible experience that tells engineers which compromises were forced, which systems were disasters, and which decisions were made only because there was no other choice. That knowledge doesn't fit in a crate. Japan spent $950,000 to buy America's rejected airliner, then spent years turning it into a bomber that couldn't bomb. Douglas spent years learning why it failed and built a success from the wreckage. Shinzan, Deep Mountain, was supposed to cast a shadow across the Pacific. Instead, it became a footnote, a warning that copying is not understanding, and the most dangerous thing you can do in engineering is to believe a shortcut is the same as mastery.